Welcome. Today's lesson is equation of parabola. Parabola is defined as the set or the locus of points that are equidistant from the both directrix or a fixed straight line and the focus or a fixed point. Parabola is a part of a conic section formed by the intersection of plane and a cone. This animation shows how parabola is produced. In the cone and a plane intersects at some angle theta, parabola is produced. For any point on a parabola, the distance from that point to the focus is the same as the distance from that point to the directrix. Notice that the distance being measured to the directrix is always the shortest distance or the perpendicular distance. The specific distance from the vertex, the turning point of the parabola, to the focus is labeled P. Thus, the distance from the vertex to the directrix is P. The focus is a point which lies inside the parabola on the axis of symmetry. The directrix is a line that is perpendicular to the axis of symmetry and lies outside the parabola. This line is axis of symmetry. This line is directrix, which is a straight line. This is the vertex of the parabola. This point is a focus of the parabola. These points are on the parabola. The distance from the focus, the distance from the focus to a point in a parabola equals the distance from that point to directrix. That is the distance from the focus to point 2 and the distance from P2 to directrix. This is also the distance from the focus to P1 equals the distance from P1 to directrix. And also the distance from the focus to P equals the distance from P to directrix. Here is a parabola opens to the right. The distance passing through the focus of a point is called latus rectum. The distance passing through the focus of a point which is perpendicular to the axis of symmetry is latus rectum. This is the latus rectum, which is the distance from this point to this point are a latus rectum. This also a line called directrix, which is perpendicular to the axis of symmetry, and the point on a directrix is h minus p and y. This is the point on the directrix. The equation of the directrix is x equals h minus p. This is the equation of the directrix, and the parabola is opens to the right. This is the focus, the vertex of a parabola. The distance from the vertex to a focus is the focal length, which is called p. The distance between two ends of the lattice rectangle is for p, which is the L equals 4p. Remember that the distance from the focal point to any point on a parabola equals the distance from that point to directrix. Using the distance formula, the distance from point P to point F equals x minus h plus p square plus y minus k square equals the distance from this point to the directrix x minus h minus p square plus y minus y square. And this distance, this is the distance from P to F, and this is also a distance from P to the directrix. This is the distance from P to focal length, and also this is the distance from P to directrix. The two distances are equal. Remember that the distance from a point P on a parabola is the shortest distance, which is perpendicular to the directrix. Here is the value of y is, here is y is, and this also y, the value of y is constant. As we already mentioned, the distance from the point to a focal point equals the distance from a point to directrix. Squaring both sides and solving gives this equation. This is the equation of a parabola and opens to the right. These are some important notes. This is the equation of the parabola. Either it is opens to the right or to the left. The vertex is hk, the focus is h plus or minus p, comma k, and the directrix x equals h plus or minus p, the axis of symmetry equals k, and the sign in front of the p is positive. If the sign in front of the p is positive, then the parabola opens to the right. If the sign in front of p is negative, the parabola opens to the left. Some important notes. Here is an example. Write the equation of a parabola whose focus is minus 1 and whose directrix is x equals minus 6. The solution is the vertex is halfway between the focus and the directrix. That is, the focus is minus 2 and the focus is minus 2 and the directrix is minus 6. Minus 2 plus minus 6 over 2 gives minus 4. And the vertex the second coordinate is k equals 1, which is constant, so the vertex is minus 4k, minus 4, 1. This is the vertex of this parabola. There is the equation of directrix x equals h minus p. X is minus 6, which is the directrix, and this is the equation of directrix x equals h minus p. X is minus 6 and h is minus 4. The question is to calculate p. Substitute all the numbers and solving. P equals 2. This is the equation of parabola when it opens to the right, which is here is a vertex 1 and minus 4. Y minus 1 square plus y minus 1 square equals 8 into x plus 4. This equation of parabola. Question number 2. Find the vertex, focus, directrix, axis, and lattice rectum of the parabola. And the equation of the parabola y square minus 4x minus 4y. And the solution using the perfect square. Using the perfect square, the equation of the parabola is like this. Using the perfect square. Here is the vertex is y equals 2 and x equals minus 1. This is the vertex of the parabola. The focus of the parabola is x plus 1 equals p, or y minus 2 equals 0, which is the focus is the focus of this parabola is 0, 2. The axis of symmetry of this parabola equals 2, and the latest rectum of the parabola is 4p. Here the value of p is 1, but the latest rectum equals 4. This is the graph of this parabola. The focus is 0, 2. The vertex is minus 1, 2. Is the vertex. And the latest rectum is 4p, which is 4. The distance from this point to this point is called the latest rectum. The latest rectum is a line which passing through the focus of a parabola. So these points are this point and this point are the endpoints of the latest rectum. This graph is all about the parabola, and the vertex is minus 1, 2, and the focus 0, 2, and the latest rectum is 4. Question number 3. Find the vertex, the focus, the directrix, axis, and the latest rectum of a parabola. This is the equation. This is the equation of the parabola. Using the perfect square, the equation of this parabola can be written y minus 5 over 2 square equals minus 3 into x plus 7 over 2. Using the perfect square, y minus 5 over 2 square equals minus 3 into x plus 7 over 2. Here is the center is 5 over 2 and minus 7 over 2. Now the vertex is these are the vertex of the parabola, and the axis is y equals 5 over 2. The focus is h minus p, which equals minus 7 over 2 minus 3 over 4 and 5 over 2, which equals minus 17 over 4 and 5 over 2. These are focus of this parabola, and the directrix is x plus 7 over 2, which equals the directrix minus 11 over 4, and the lattice rectangle is 4 times p, which is 3. This is the total length of the lattice rectangle, which is from this point to this point. The total length of the lattice rectangle is equals 4p. P is minus 4 over 3, which equals, this is the total length of the lattice rectangle. The total length of the lattice rectangle equals 4p, and the vertex of this parabola minus 7 over 2 and 5 over 2, and the focus is minus 4.5 and 2.5. The second coordinate is constant because of the parabola is opposite to the left. That is the end point of the lattice rectangle. It's all about the graph of the parabola when the vertex is minus 7 over 2 and 5 over 2, and the focus is minus 4.25 and 2.5. And the lattice rectangle is 3, and the focal length is 3 over 4. And also the equation of the parabola intercepts upward or downward. Remember that. The distance from the focus to a point to any point on a parabola equals the distance from the point to a directrix. The same method is used to prove the equation of the parabola. Here is the distance from the point on a parabola to a focal point, which is x minus h the whole square plus y minus k plus b the whole square equals x minus x square plus y minus k minus b square. This is the equation of parabola.